Connective tissue is literally everywhere in the body, but most people tend to overlook it and not realize it immediately. So, in the next few minutes, I'm going to be breaking down what connective tissue is, what it's made of, and how it works. Hi, everybody, welcome to the second episode, part B of the Anatomy and Physiology series. My name is Ridhi Sreenivas, and today we're going to be talking about connective tissue. So, to review, a tissue is a group of the similar or same types of cells that work together to carry out certain functions. And the study of tissues is called histology. Now, there are four main types of tissues in the human body that we're going to be focusing on in this series, which are epithelial tissue, connective tissue, muscular tissue, and nervous tissue. And today's focus is connective tissue. So if you'd like to check out the video where I talk about epithelial tissue, I'm going to link that in the comments, so feel free to check that out. But let's get right into it. So connective tissue is often called supporting tissues, is a very large group of different types of tissues, but most connective tissues share these three components, which are having specialized cells, extracellular protein fibers, and an extracellular matrix composed of ground substance, which we're going to talk about in a bit. But the prominence or the amounts of these components varies depending on the type of connective tissue. But before I go into classifying, like doing all that classifying stuff, I'm just going to talk about the general functions of connective tissues, which include protection, support, transporting molecules, defending the body from pathogens, and storing energy in the form of fat, which is to do with a more specific type of connective tissue, but we'll go deeper into which types of connective tissue perform which functions in future videos. So, like any other tissue, there are ways to classify connective tissues, and the classifications, again, are really important because structure tells us function, and the structure of something can give us clues to the functions of it. And by knowing this, it can help us advance our knowledge of what might this organ that has this tissue does and its properties so we can diagnose issues accordingly. And so how we classify types of connective tissue is based on these three characteristics that make them all similar or related, but it's just those differences of what types of cells are there, what types of fibers are there and the amounts of them, and then the amounts of ground substance can also kind of determine and differentiate the types of connective tissues. So just those differences in types and concentrations can, classify them and make them different, but same characteristics that make them similar. So first, I'm going to kind of go into each characteristic of it and talk about the components in those categories kind of. So I'm going to first talk about what cells can be found in the connective tissue. So let's get right into that. So connective tissue cells can either be fixed, meaning they stay in one place, or migrating, meaning they move through the tissue. For instance, if they need to rush to a site of injury. But again, these aren't really strict categories because most cells can do or can be part of both groups, like in times of injury, but it's just categorized, the cells are just categorized mainly in which one it is in. So let's first go through cells cells that are commonly seen as fixed cells. So first we have fibroblasts, which are the most abundant cells in connective tissue that secrete protein fibers as well as ground substance components like proteoglycans and glycosaminoglycans. And these components are secreted are used to make this thick gel-like ground substance that provides support under stress. And a major function of ground substance is to act as a physical barrier against pathogens so that, when the pathogens are kind of in this substance, it gives them a harder time to move through the sticky substance and easier for like phagocytes to come and engulf them. And this is a little picture of what they may look like, or yeah, what they generally look like. So next we have fibrocytes. Next we have fibrocytes. And these are usually the second most abundant cells in connective tissue, and they are the resting form of fibroblasts. And they are cells that maintain the connective tissue fibers. So there's an interesting relationship between fibroblasts and fibrocytes, because fibrocytes can differentiate into fibroblasts and fibroblasts can reverse and differentiate into fibrocytes. And the way you can think about that is like that correlation is that like fibrocytes are the resting version and fibroblasts are the more active version. So when repair and healing needs to happen, fibrocytes can transform into or differentiate into fibroblasts. And when the body is like, is that usual? Is that normal? Those fibroblasts can transform or differentiate back into fibrocytes to maintain the environment. And this is what they look like. Next, we have adipocytes, which are also known as fat cells that store energy, being the main component of adipose tissue, which we will talk about in the future. And this is what they look like here. And next we have mesenchymal cells, which are stem cells, meaning they are cells that don't have a specific job yet, but they can differentiate into another type of, like any type of cell, depending on what is needed at the time. Like, especially in times of growth and repair, they can differentiate into those needed cells. And this is what a mesenchymal cell looks like, and it can basically differentiate into any of the cells needed. These are just a few examples of cells. Now let's look into some common migrating cells in connective tissue. So first we have macrophages, which are phagocytic white blood cells. So I don't know if I said that right. Phagocytic? Because like phagocytosis. Okay. So basically these are white blood cells that basically engulf or eat damaged cells or pathogens in this tissue, helping the body with the defense system. And some of them can actually be fixed into one area while others can migrate when needed. So they technically fit into both categories. But they honestly just help with the defense system because like when pathogens get stuck into the ground substance, they can come and just get rid of them. Get rid of those pathogens. Next, we have mast cells, which release heparin and histamine in response to pathogens and allergens to initiate a defensive response in the human body. That's like them releasing their products, like heparin and histamine. Next, we have lymphocytes, which fight infections and work with the immune system to target pathogens. And then we have neutrophils, which are these fast-acting white blood cells that respond first to the site of injury, but they have a shorter lifespan compared to macrophages. So now let's look into connective tissue fibers in connective tissue. So there are three main types, all made by fibroblasts, and they are maintained by fibrocytes. So first we have collagen fibers, then we have reticular fibers, and then we have elastic fibers. Sorry, they're made of elastin, but they're called elastic. Make that more clear. Hold up. They're made of elastin, but they're called elastic fibers. Okay. So first we have collagen fibers made of type 1 collagen, and they are long and straight and unbranched fibers that are flexible while still being strong. Like if you think of like a rope or something, like a rope, they can move around and have the ability to wrap around things, but if you pull on the rope, it is hard to break, so it's still strong. yet still flexible. And collagen is mainly known for its tensile strength. Next, we have reticular fibers, on the other hand, being composed of the same proteins as collagen, but the proteins are arranged differently, as it is made of type 3 collagen. And therefore, they have different properties, being more thinner and are more delicate compared to collagen fibers, but still strong enough. So reticular fibers are mainly known to support soft organs like the spleen or liver, and many more, of course. Next, we have elastic fibers, and they're made of elastin, being more wavy and branched as well, allowing tissues to stretch and then return to the original shape, like a rubber band. That's their kind of like property, to be able to be stretched and recoil back. That's the property they give to the tissues that have them. And this is a little like general picture I have right here that shows the comparison between collagen fibers being much more thicker and these elastin fibers being thinner, but like are branched, and you can just kind of see the comparison between them. But now let's talk about ground substance, which is this gel-like material that fills spaces between cells and fibers. It is made of glycosamin glycans, proteoglycans, and glycoproteins. It is viscous and it has a sticky texture, and this supports tissues and slows the pathogen movement once pathogens get stuck in it. And when pathogens get stuck in this like substance, this allows and helps phagocytes to catch the invaders much easier, and engulf the invaders and get rid of them. So now that we've looked at the three features used to classify connective tissues, the types of cells, the types of fibers, and the amount of ground substance, these features are used to group connective tissues into these three categories: connective tissue proper, fluid connective tissue, and supporting connective tissues. And we'll talk about connective tissue proper in the next video. But that is the end of this video, because I just want to give you guys a general understanding of the components of connective tissue in general. But if there are any questions or things you are specifically curious about this type of tissue, then please feel free to comment those down below, and we can definitely discuss them. But anyways, thank you so much for watching this video, and stay tuned for future videos.